Alright, this next video is on review with factoring by difference of squares. So, this is a specific factoring method. It only works in certain cases. We'll see what those are here. There's only a short set of practice because it's a pretty quick factoring method, but if you need extra help at the end, just ask your teacher. Alright, so let's review here. We're going to use the distributive property to simplify x plus 6 times x minus 6. So here I'll have x times x, which is x squared. X times negative 6 is minus 6x. Here I'll have plus 6x. And positive 6 times negative is minus 36. When I combine like terms here, notice I have negative 6 and positive 6. Negative 6 plus 6 is going to cancel out to be 0. And I'm left with x squared minus 36. Let's try the other one, see what happens here. I'll start with 2x times 2x, which is 4x squared. 2x times negative 5 is minus 10x. Plus 10x. And 5 times negative 5 is minus 25. Well, look what happens. I have negative 10x, positive 10x. Again, those cancel off. So I'll have a 4x squared minus 25. So you should notice that something happens here. First, a pattern that happens is that there's no just x term. Right? We have an x squared, we have a constant, but we don't have an x term. Both times those canceled off. There's a subtraction sign in between both sets, right? They both have a minus sign. And then it looks like each term, the x squared 36 is the square of what I started with. X squared down here, and 6 squared is 36. So same over here, 2x, the quantity squared is 4x squared, 5 squared is 25. So I'm not going to write that because it's kind of hard to put into words, but each part of the answer, each term, is the square of a term in the original problem. So let's talk. We're talking about squares here. That seems to be what's happening, right? We had a lot of things that x squared 36, 4x squared 25. I see numbers that look familiar. Let's talk about perfect squares here, right? A perfect square is a number that you get when you square something by itself. So like 1 squared, 1 times 1 is 1. 2 squared is 4. 9, 16, 25. I want you to take a second, pause the video, fill in the rest of these. You're going to need to know them, so go ahead and pause me here. All right, so you should have all of these perfect squares filled in. You need to know them. You should know how to work with them and how to find their square root. Does it make a difference when a number is being squared if it's positive or negative? No. The reason is because when you square a number, you are taking that number times itself. So if you have a number like 3 squared, that's taking positive 3 times positive 3. And a positive times a positive gives you a positive. Right? But for example, if I'm multiplying negative 3 the quantity squared, that's negative 3 times negative 3. And you should know that a negative times a negative gives you a positive. So no matter what, if I square a positive or negative number, I'm going to get a positive answer. So this all leads us to our factoring method. There's a pattern that we're going to follow, right? So difference of squares. Difference, keyword here, means subtraction or minus sign. So this pattern only works when there's subtraction. Difference of squares means I'm going to have 2 perfect squares or values that you can take the square root of. So here if I have a squared minus b squared, what we're going to do is we're going to take the square root of a squared, which is a, and then the square root of the second term, b squared, which is b, and use that a and b. the pattern we're going to follow is this. That square root of a squared, a is going to go in both. The b is going to go in both. That's the second square root. One set is going to get a plus. One set is going to get a minus. Now you should think that looks a little familiar maybe back from the top here. We had the same terms in either parenthesis, plus and minus. Plus and minus. So you're going to have one of each sign. The second part here looks very similar, a squared plus b squared, but here's what you have to watch, the plus. When you add, that's called a sum. And we're looking at what's called the difference of squares. So this actually does not factor, and we call that prime. So anytime you see a plus in difference of squares, you cannot do it. Now the other thing to remember, difference of squares will only happen when you are given two terms, binomials, not if there's three terms. So you have to have two terms, a minus sign, and two numbers you can take the square root of. Let's try a few on the back. All right, so we're going to have m squared minus 4. So for now, at least in the notes, I'm going to do the long way here, and I'm going to write out that we need to find the square root of m squared, square root of each term. Well, the square root of m squared is m, and then I need to find the square root of the second term, 4, which is 2. I'm going to use the m and the 2 when I factor here. I bring the m into the first and second parentheses, the 2 into the first and second, one set gets a plus, one set gets a minus. Now let's practice distributing here just to make sure we understand how to check our work and that this works out okay. M times m is m squared. M times negative 2 is minus 2m, plus 2m. 2 times negative 2 is minus 4. Notice negative 2 and positive 2 cancel off. So I'm left with m squared minus 4, which is what you started with, so you know you factored correctly. Now, one thing I didn't do in the first column is you have to make sure there is a minus sign and there's no GCF. So when I look at number 2, I have 49x squared minus 81. I do have a minus sign, so I'm allowed to do the difference of squares. And then I look for a GCF. 49 and 81 don't have anything in common. So I can go ahead and take the square root of each term. All right, the square root of 49x squared is 7x. And the square root of 81 is 9. So you're going to use the 7x and the 9 when you factor here. And just like the last problem, you're going to have two parentheses that look the same. They each get a 7x. They each get a 9. One gets a plus, one gets a minus. That is your final answer. All right, last one here. 25x squared plus 16 is their GCF. 25 and 16 doesn't look like it. Now I look for the minus sign. Oh, I don't have a minus sign this time. I have a plus. That means I'm done. I can't do anything. So this is prime. We can't move on. All right, next row of problems. 16 minus x squared. First, I look for a GCF. 16 and x squared, no GCF. Second, I look for a minus sign. There is a minus sign, so I can go ahead and see if I can take the square roots. The square root of 16 is 4, that works. And the square root of x squared is x, so that also works. Let's use the 4 and the x. All right, remember, a 4 goes in both sets of parentheses, and x goes in both. They have to go in the order as they started. 4 on the left, x on the right. One gets a plus, one gets a minus, which I wrote wrong. Minus, and that's it. That's your factored form. Again, you can check your work here. Distribute. 4 times 4 is 16. 4 times negative x is minus 4x. Here's plus 4x. Again, notice those are going to cancel each other off. X times x is minus x squared. So I'll have 16 minus x squared, which is what you started with. Okay. 5, x squared minus 1. Look for a GCF. There isn't one other than 1. There's no GCF, so we're not going to factor GCF out. I do have a minus sign, which means that you are allowed to use this factoring method. So you're going to take the square root of each term. The square root of x squared is x, and here the square root of 1 is 1. So I'm going to use x and 1 in that order to factor here. An x goes in both, 1 goes in both, a plus and a minus, and then you're done. Right, number 6, 100r squared minus 9. Look for a GCF first. 109 don't have anything in common. I do have a minus sign in the middle of the two terms, so I can factor by difference of squares. So I'll try. Square root of 100r squared is 10r, and the square root of 9 is 3. So we use the 10r and the 3. 10r in the first and second, 3 in both, a plus and a minus. So you're all set. You're factored there. All right, 3 more we can try. 27x squared minus 12. I start by looking for a GCF. 27 and 12 actually do have a GCF. That would be 4. So I'm going to, I'm sorry, not 4. It would be a 3. I'm going to divide 3 out of both terms. When I do that, I have 3 in front of my parentheses. 27 divided by 3 is 9. Bring down the x squared. Minus 4 here. Now, every time I pull out a GCF, I have to determine if I can factor any more. So I look at the 9x squared minus 4. It does turn out that you can factor this again. So you're going to take the difference of squares because there's a minus sign here. The square root of 9x squared is 3x, and the square root of 4 is 2. So when you factor this, you must bring down the 3. You can put parentheses. I'm just going to put a square bracket. It doesn't matter. You have to bring down the GCF. Inside, then, you're going to put your regular other factored form. So 3x in both, a 2 in both, a plus and a minus. Now, do you technically need those big square brackets? No, you don't. If you wanted, you could write this as 3, just parentheses 3x plus 2, 3x minus 2. It's the same thing. It does not matter. All right, 50 plus 98x squared. So I first look for a GCF, 50 and 98. I think 2 goes into both, so let's try dividing by 2 to see if that'll work out. I'll divide a 2 out, which will give me 25 plus 49x squared. That did work. All right, now I look and decide, can I factor what's in the parentheses anymore? Well, they're both perfect squares, but notice there is a plus sign there, which means you cannot factor anymore. Now, this is not called prime. I don't want to see prime on your paper. You already factored. You did factor out a GCF, so it's not prime. However, the inside part just can't be factored anymore, so this is as far as you can go. Number 9, let's finish our last problem here. Do I have a GCF? No, 36 and 1 don't have a GCF other than 1. There is a minus sign, so I can do difference of squares. The square root of 36 is 6. The square root of x squared is x. I'm going to use the 6 and the x when I factor. Both parentheses get 6. We have to do that one first. The x has to go on the right. One gets a plus, one gets a minus, and you are all set. That's your final answer. All right, 6 quick problems on the bottom to try as practice. There will be a short video on a couple of those as well. Ask your teacher if you need help with any of this.